Hello, I'm Emily from emilylearning.com. In this video, I'll be going through how to tackle this structural elucidation question, which is a quite common question in H2 A-level chemistry. So let's go through this structural elucidation question. So we have succinic acid, which has a structure of COOH, CH2, CH2, COOH. In other words, you see two COOH group at the ends of this compound. Okay, and this acid, right, can be synthesized from bromoethanol via a series of reactions. So we know what is bromoethanol, and we can actually draw out the structure. So let me do that. So let's draw out the structure of bromoethanol. So we know that since this compound ends with the letter Al, it is an aldehyde, okay, and there is a bromo group. So I know that I have an aldehyde. So an aldehyde group is CHO, okay. So it looks like this, okay, because it is E. So there are two carbons. So bromine must be on this carbon here, okay. So this is bromoethanol. And if you look at the structure of bromoethanol here, there are two functional groups. One of it is the halogenal alkane group. So we'll think about nucleophilic substitution and all reactions associated with halogenal alkane. And the other functional group is your aldehyde group. Okay, so now let's look at the next sentence. So bromoethanol was reacted with HCN in the presence of KCN to form W. And we know that W takes this form C3H4BrNO. Okay, so initially bromoethanol only has two carbons. Now the number of carbon increased by one. This is a step-up reaction. So for structural elucidation, right, when you see a step-up reaction, okay, it will definitely either involve your your halogenal alkanes or your aldehyde groups, and we have both of them here. So which of it is it? Okay, so if you have HCN in the presence of KCN, then we know that this is the nucleophilic addition reaction, because for nucleophilic addition reaction of aldehyde, we will use HCN in the presence of trace KCN or HCN with trace NaOH. Okay, if it is a nucleophilic substitution reaction with halogenal alkane, then it will be KCN, ethanolic KCN, and heat. Okay, so we know that, okay, this HCN in the presence of KCN is going to react with the aldehyde group. Okay, so I know that this group is going to react, and this C double bond O group will become CN and an OH. So CN will be added here and H will be added here. Okay, so I know basically with this sentence, I know what W is now. So I know W will be CH2Br, and I'm going to do an addition on the aldehyde group. So it will be OH here and CN here, and there's a H here. All right, so this is W. So now I already know W. Next, W then react with reagent U under appropriate conditions to form C4H2N2O. Okay, so if you to compare this, right, C4H2N2O versus C3H4BrNO, you notice that the number of carbon between W and X has increased by 1. Same thing, the number of nitrogen has increased by 1. Okay, but I lose the Br. So in other words, right, it tells me that to go from W to X, I lose a Br and I replace it with Cn. So it tells us that this reaction with reagent U involves substituting Br with Cn. Okay, so I know that to form X, I am going to replace the Br group with the Cn group. Okay, so this will be my X. Okay, now I know what is my X already. Let's go on. So upon heating X with dilute hydrochloric acid, I get Y, which is C4H6O5. Okay, so basically if I look at X, right, the two functional groups present would be your CN group and your OH group. So heating with dilute acid, this is a acid hydrolysis reaction. So we know that CN group undergo acid hydrolysis to form COOH. Okay, and finally, I know that the number of oxygen has increased by 4. Okay, and there's no more nitrogen. So it tells us that both this CN group will undergo hydrolysis to form COOH. All right. Okay, so I know it becomes COOH here and CHOH, COOH, and this will be my Y. Okay, so now after the acid hydrolysis, I form Y. Okay, and after Y, next I'm going to heat Y with concentrated sulfuric acid. So when you see the word concentrated sulfuric acid, it's usually a dehydration reaction. So what are the reactions that use concentrated sulfuric acid? One of it is the dehydration of your alkenes. Okay, sorry, dehydration of alcohols to form alkenes. The other one is the reaction between alcohol and carboxylic acid to form esters. Okay, so for this, I have a OH group, so I know that this reaction involving concentrated sulfuric acid will be the dehydration of the alcohol. And for dehydration of alcohol, I'll remove the OH and H from adjacent carbons. Okay, and when I remove this OH and H, right, I will have a double bond. Okay, to check whether we are correct, you can also do it this way. I look at the formula of Y, which is C4H6O5. I look at Z is C4H4O4. So if you were to compare this two formula, you notice that from Y to Z, I actually lose 2 hydrogens and also lost 1 oxygen. So in other words, I lost a H2O. Okay, so it's a dehydration reaction. Okay, so now let's draw Z. So I will form an aldehyde, sorry, alkene. Okay, okay, and this will be the structure of Z. Okay, then I'm also told that for Z, okay, it is a dicarboxylic acid with molecular formula. Okay, so C4H4O4, so this is Z. And subsequently, introduction of H2 in the presence of platinum catalyst will convert Z to succinic acid. So if I look at Z and succinic acid, I know that what it lacks is 2 hydrogen. So the H2 in the presence of platinum catalyst is basically a reduction reaction or a hydrogenation reaction of the CC double bond in alkene. Okay, and the CC double bond then becomes CC single bond, and you'll form succinic acid as a result. Okay, so let me draw it out. So I have this COOH, CH2, CH2, COOH, and this is my succinic acid. Okay, and next I'm also told that, right, if I were to add hot acidified KMNO4 to Z, an acidic gas will be produced. So why is the acidic gas? Okay, if you look at it, there are so many carbon. Very likely the acidic gas is carbon dioxide. Okay, and it is so. So remember, when you add KMNO4, it is an oxidation reaction. So we know that there's a CC double bond. The CC double bond will undergo oxidative cleavage. Okay, and when it undergoes this cleavage, so this bond breaks, right? So let's draw what it happens to it. COOH, and it forms COOH here. So same thing for the other side, it also forms COOH and COOH. And there's a name for this compound, right? There's something special about this. This is ethane dioic acid. So most carboxylic acids are very stable to oxidation with KMNO4. There are some exceptions. One of it is methanoic acid, and the other one is ethane dioic acid. So in the presence of acidified KMNO4 and heat, ethane dioic acid will be further converted to CO2 and H2O. Okay, so therefore we know that at the end of the day, when we do an oxidation on this compound Z, we will get carbon dioxide and water. So the acidic gas that is produced and mentioned here is actually carbon dioxide. Okay. Okay, so now we know what is X, what is Y, what is Z. And I have also gone through the deductions based on this here. So let's look at how to format our answers for the A levels. All right. So if you're interested in looking at it, I also provided detailed solutions at this website here, which I will provide in the link in the description below. So do check it out. Okay, so now let's look at how to answer structural elucidation question, or how to format your answer for the A-level exams. All right, to structure your answers, right, for a structural elucidation question that asks you to both explain and give the structure, this would be how you present your answer. So you draw a table, okay, and the table has one column being the statement and the other column being the deduction. So the statement is basically copying from the question, and the deduction is based on that statement inside the question. What can you deduce? You can write in terms of functional groups, in terms of number of functional groups, and so on. All right, or structure and so on. Okay, then based on all this, you will come up with the structure. Structure A is this, structure B is this, and so on. Okay, so since in just now's question we have already determined the structure of W, X, Y, and Z, so let's first answer the question by writing the structures. All right, so these are the four structures W, X, Y, and Z that we have found. Okay, so I have already deduced the structure W, X, Y, and Z. So okay, I will get 4 marks for the structures. So the rest of the marks goes to deducing the structure based on what is written in this question. So let's look at how do you answer the deduction portion. Okay, so this is how you answer. So you set up the table with statements and deductions. I know this is a bit small, so if it's small, please refer to the website here where you can see these answers here clearly. So how I will do it is I'll do it statement by statement. So I know that okay, bromoethanol react with HCN in the presence of KCN to form W. So I write down this statement. So I know that this reaction is a nucleophilic addition on the aldehyde group of bromoethanol. Okay, and the product form will have an OH as well as a CN group. So I'll write that in. Okay, next I will go on to the next statement. W was then reacted with U to form X. Okay, and X has this formula. So once I write this down, what I can conclude is that the halogenol alkane group. So I know that, right, to go from W to X, right, I lose a Br and I gain a Cn. So in other words, it is a substitution of the Br group with a Cn. And this is a nucleophilic substitution reaction. So I will deduce, what I write down as a deduction is a nucleophilic substitution of the halogenol alkane or the Br group has occurred, and it is now replaced by a Cn group. Okay. So because I know that to form W, one of the aldehyde group becomes a CN group. To form X, the Br group becomes a CN. So in other words, right, at the end of the day, X has two CN groups. Okay, one is from this reaction and the other one is from this reaction. Okay, now I've done with this sentence. Next, I'll go on. Okay, heating X with dilute hydrochloric acid will give Y. So heating X with dilute hydrochloric acid, this is an acid hydrolysis reaction, and it converts a CN group to a COOH group. So I'll write that down here in my deduction. Okay, then next I'll talk about Y. Y was then heated with concentrated sulfuric acid to form Z, which is a dicarboxylic acid with this formula. Okay, so this is the statement. So I know that the elimination reaction has occurred. Water is eliminated. So Z will have a CC double bond. Okay, next, let's look at the next sentence. So I form Z. So subsequent introduction of H2 in the presence of platinum catalyst will convert Z to succinic acid. So I know that this is a reduction reaction, and I'm going to hydrogenate the CC double bond in this reduction reaction. So the CC double bond is going to become saturated and becomes a alkane group. Okay. So what I'll write is I'll first just simply copy this sentence. Okay, adding H2 to platinum catalyst will convert Z to succinic acid. So this means that the CC double bond in Z is converted to an alkane. All right. Then it's here. Then finally, I know that when hot acidified KMNO4 was added to Z, only an acidic gas was produced. So this is the statement, and I'm going to write the deduction. The gas is CO2. All right, so this is how you write the deductions, or how you present your answer for a structural elucidation question. Okay, so for more details, or you want to go through it by reading, you can check out this post here or this website here, where we go through this question in detail.